So now do integration by parts. So integration by parts is an integral of this kind. You're integrating u that is being multiplied by dv. So these will be two functions that you make a choice. You're going to make a choice for what you are going to call u and what you call dv. And what you call dv. Okay. Then if I have u dv, I'll keep u and look for v to multiply here, and then subtract, then integrate v and multiply it by du. Meaning you pick u that you can easily differentiate. And you pick dv that you can easily integrate. Because for you to get, you integrate dv for you to get v. And you differentiate u for you to get du. And then you form that combination here. Examples. The first example we'll pick is the integral. This is from question 7. The integral of 8x multiplied by e to the power 7x dx. So you want to think of substitution. If you were to use substitution in this integral, you should have at least one value, one power of x higher than the other. But here the powers of x are equal. So if you try to let u be 7x, its derivative will be 7, nowhere near 8x. And this is how you know which method to use. You think of a method and check what that method requires if you're able to find it there. Substitution demands that one power is higher than the other, or the other part is the derivative of the other thing. Now, in this case, we have two independent functions being multiplied, not related at all. The derivative of 8x is not e to the power 7x. The derivative of e to the power 7x is not 8x. So what do? We'll go back to by parts and say, okay, maybe we can use by parts here. If you had to use by parts, the best choice would be to let this piece here to be our u. So I'm saying u is 8x. What will be du? Du will be 8 multiplied by the x. And then dv, e to the power 7x dx. When we integrate dv, if we integrate dv, we're integrating this. To integrate this, remember we said you differentiate the power of e. It is 7x. So when you differentiate 7x, you get 7. So you have e to the power 7x divided by the derivative of the power, which is 7. That is to integrate. To differentiate, you multiply by the derivative of the power. To integrate, you divide by the derivative of the power, provided it's a constant. So,
Because if I wanted the doublet U to be the other one and V to be the other part.
yeah, and then you see the consequences of such a choice.
Okay.
So we'll come and demonstrate that what if you made the wrong choice? What could happen? So for this one, we've now said, remember here we're saying to integrate, once you have identified your U, you have found your V, you have found your DU, you have your DV, then you multiply U by V. So this is going to be the integral of 8x e 7x dx is now equal to U multiplied by V. That will be 8x e to the power 7x. We divide by 7. That is U times V. This 2 minus the integral of V, which is e 7x over 7 multiplied by du, which is 8 dx. So we can write this. We're having 8 over 7 x e 7x minus 8 over 7, the integral of e 7x dx. Now for exponentials, we have already integrated e to the power 7x. It's here. So we just copy it. So we have 8 over 7 x e to the power 7x minus 8 over, remember the integral of this has over 7 down. So that's 7 multiplied by this 7, we'll have 49. And then e to the power 7x plus c. So from here, what I'm trying to explain is we have 8 over 7. When we integrate e to the power 7, we get e7 over 7. And then plus a c. But 7 times 7 here, we're getting 49. Now, let's get back to the question of what could happen if you said, let u be equal to e to the power 7x. Well, you would easily differentiate. Your du will be 7 e to the power 7x. Your dv will also be nice. It will be 8x dx. And you can easily integrate. How do you integrate? 8x squared over 2, which you can write as 4x squared. When you make a combination now, you're integrating e. So you're now integrating 8x e to the power 7x dx. What do we get? So you have uv, that is 4x squared e 7x minus the integral. So we have 7 over 2. 7. So we have the integral of 7 e to the power 7x multiplied by 4 x squared dx. This product has now become like 7 times 4, that's 28. Integral of x squared e 7x dx. This integral has become more difficult than the one we have in the question. The one we have in the question is the integral of x to the power 1. What we have here is now x to the power 2. It's becoming even more difficult to integrate than the original question. So if you make a wrong choice of u and v, you may enjoy the first step and get stuck in the second step. That's why it's important to check that when you say u and dv, they are helping you in reducing the complexity of the second integral.
So, sir, how do you choose? Like, is there something that might tell you for no, okay, this one is easy to differentiate, this one is easy to integrate? Or maybe
Yeah,
just how
I'll
do
give
you?
you the general combinations later, not today. That will be helping you after you've struggled a bit, then you appreciate them. So let's do another one. So here we're saying, note this. Okay. Another one, we'll go for D. How does this combination work? How does this combination work? E to the power negative x, then sine of 4x. So this one is a very a tricky question, because here we talked of having the complex in the second integral. But here's a situation where any choice that you make will still give you the same combination. So, well, it depends with what you like. If you have no difficulties in differentiating sine, you better let sine be u. If you have no difficulties in integrating sine, you better let dv be sine. But I'm so sure that we have less difficulties in differentiating sine as compared to integrating it. Because integrating is an issue of when does it become minus. So we'll let u be sine 4x and dv be e to the power negative x, so that we treat this as u at dv. So we'll differentiate u. To differentiate sine, you differentiate the angle. The derivative of 4x is 4. And then you differentiate sine, you get cos, and then you multiply by 4x. Then we integrate v. To integrate e, you write it as it is first, and then differentiate its power and divide here. So this is going to be negative e to the power negative x. So what will be the integral? We'll have uv minus the integral v du, which is u v is negative e to the power negative x, and du is sine 4x. Then minus the integral of v du. So I'll write the 4 outside here, and then I'll write e negative x, and then cos 4x dx. So now what I will do is I haven't used this minus here. So I want to use that minus by multiplying it with this minus here to make this one positive. Because remember the formula has a minus and then e has come with a minus. So minus minus will get a positive. Then now I want to integrate this again. So you make the same choice. So you let u be cos 4x so that our du will be, we differentiate 4x, we get 4. We differentiate cos, we get negative, sine, and then keep the 4x. And then our dv is going to be e to the power negative x. Then integrate, we'll get negative e, negative x. Then we come back here and say, so we're having, on the left, we have the integral of e minus x sine 4x. This is equal to, we copy this, minus e minus x sine 4x plus 4, this 4 here, multiplied by, what is uv? So uv, that's minus e negative x cos 4x. This minus the integral of u, which is of v du. So v is minus e minus x multiplied by minus 4 sine 4x dx. So this minus times this minus will have a plus. So we're going to have the integral of e minus x sine 4x dx is equal to minus e minus x sine 4x minus 4e minus x cos 4x minus minus, we get a plus, so this minus 2 remains. And then we can put the 4 outside. Then we'll have e minus x sine 4x dx. But look, we still have the same combination. But the good news is that this thing we have here is exactly as what we have on the left. So we can actually take this other side so that now we have the integral of e negative x sine 4x dx plus 4, the integral of e negative x sine 4x dx is equal to minus e negative x sine 4x minus 4 e negative x cos 4x. Then these two we can add, and we're getting 5 integral of e negative x sine 4x dx is equal to minus e minus x sine 4x minus 4e minus x cos 4x. Then divide by 5 and divide by 5. So get the integral of e minus x sine 4x dx is equal to 1 over 5. I can put the minus and then open and write e minus x sine 4x plus 4a minus x plus 4x, like this.
Plus C.
Plus c, yes. So if you forget that you have similar things on there, right there, and then that you can take the other side, this question can never end. You keep on making the combinations and keep on doing that, keep on doing that. So mostly the combinations of E and sine or E and cos, you have to integrate twice and then do the addition for you to get to the answer.
So how you steps one time with sign and mess up with everything.
I can't get you.
I mean, with all these steps, once I mess up with a sign, then everything is
Yeah, if you try to mess up with a sign, the first thing is that your answer is wrong. But when you talk about marks, you may negotiate 1 or 2 marks.
Sir, at what condition are we supposed to differentiate twice?
Every time you have a combination of E and sine, the one way you get to the answer is when you do the addition. So you're forced to do the integral twice so that it changes the form back to sine. Because the first integral takes you to cos, the second takes you back to sine. So what is
All right,
key is just, so what's key in this question is knowing the formula. If you know the formula for by parts, then pick any combination that you pick, you will reach the solution. Okay, let me try to pick a different setup. Let's see. On question 9, let's go for A. The integral of 9 over x squared minus 12x or dx. You can't surrender. If you wanted to surrender, you're not supposed to join this class. Because this class will make sure that you're clear. Because you'll see what will happen next week. You even have the confidence that, okay, I think now I have to just face the exam and just clear it and forget. That's our mission here. If I have the integral of this nature, you try to think, can substitution work? Substitution would require that the numerator has at least x, that is the power 1. And then, what about by parts? By parts requires that when you integrate anything, differentiate the other, the next thing must make sense. So here, the first thing you should think of is, what happens if I just break this into some partial fractions that I can easily maybe integrate? So you'd pick your 9 over x squared minus 12x. This time around, we write it as x multiplied by x minus 12. And then partial fractions, we get a over x plus b over x minus 12. We're doing the normal partial, so you cross multiply. You cross multiply by x minus 12. So we'll get 9 is equal to a x minus 12 plus bx. And then when x is 0, we'll have 9 is equal to minus 12a, giving us a as 9 over negative 12, which is, if you divide by 3 there, you get 3 over negative 4. We come back. What happens if we let x to be positive 12 itself? Then we'll have 12 minus 12, 0. So we get 9 is equal to 12b. That will mean b is 9 over 12, which is 3 over 4. So you come to integral now and say, this integral is now equal to the integral of, where there is a, we have minus 3 over 4. Or first I write it the way that we will understand. Minus 3 over 4, that is a over x. And then the x plus b, the integral of 3 over 4 over x minus 12, and then dx. So this will give us minus 3 over 4, the integral of 1 over x dx, plus 3 over 4, the integral of 1 over x minus 12 dx. We wanted to bring it here where we can see that, oh, it's easy now for us to do some substitution. If you look at this looks like the derivative of ln x. Because if I have ln x, how do I differentiate? I differentiate x to get 1, and then divide by x. So this is a term when we use ln. So we have minus 3 over 4 ln x plus 3 over 4. The same thing is happening here. If you think of the derivative of ln x minus 12, we are going to have the derivative of x minus 12, which is 1, and then divide by x minus 12. Exactly what we have here. So we have ln of x minus 12, and then plus c. So when you check, power rule can't work. Substitution can't work. By parts can't work. Then you try to look around and say, oh, am I able to break this? This is the question that you asked to say, what could happen if the power is bigger, the space is more than 1? The difference between the powers is more than 1. This is what you'd resort to. You think of breaking into partial fractions. So that you remember the partial fractions, we said that the power of the numerator is supposed to be less by 1 the power of the denominator. It's because we want to be using it to integrate some setups when we thought to integrate using those methods that we know. So there are questions that will push us to get to this partial. Some will take us to by parts, some will take us to substitution, some will take us to power rule. But how do we know which one is which? That's why now specializing as we do the revisions starting over the weekend. You see that, I'm aware that there's a physics test on Sunday. So I may give a space for that test. And then, so that when we hit, even you guys will know that, okay, the only thing that we need to be more serious about is the math that is the first paper. First paper should motivate you and not demotivate you. So you need to be prepared enough for it. So I know many of you like, so I can see the attendance is very low. And then obviously you're waiting for the video. But starting when we just hit the exam preparations, our videos will be restricted to not public view, but only those who are in the group. So I'm going to use the membership setup for YouTube. So if you happen to miss a class, you better inbox so that I'll get you the link. So we'll end here today. And then we'll see how we progress in the group. We'll communicate. Okay.